Welcome everyone. I would like to start from scratch so that everything will be understandable. Initially, I'm selecting my analysis system. Double click Fluid Flow Fluent. Click Geometry and make sure your analysis type is 2D since we are conducting 2D analysis. Right click Geometry, New Design Modeler. I will go a little fast so that we won't waste any time. If you need to understand again, just rewatch the video. Now I need to import my airfoil geometry. Click Concept, 3D Curve, click millimeter. Make sure your coordinate unit is millimeter. Select your airfoil coordinates file from desktop, NACA4412, or it should be on desktop. Just a second, yep. Make sure your selected file is text and tab delimited. Click Open and hit Generate button. You can zoom fit to see your airfoil. Perfect. Now we need to make sure that ANSYS understand that our surface or airfoil is a surface body. So click Concept, Surfaces from Edges, click your airfoil boundary, and hit Apply on the details view. Hit Generate. Now ANSYS understands that our airfoil is a surface body. Now we need to create and make sketching. Click the sketch and make sure you selected Arc by Center on the very left panel. Click P. Click the very front of your airfoil. Make sure P letter is visible. Point. Select anywhere on the y-axis, positive y-axis, and go left. Go to the minus y-axis and select anywhere else. It doesn't matter, but C letter should be visible. Click Dimensions on the Toolboxes panel. Give a dimension give a radius to our whole circle. The value is 7.5. Roll down to be able to see the whole sketch. Now we need to draw another line. Make sure it is horizontal. Select it from here. And sorry, before we need to make this dimension as 15. In general, select it, click it, and make sure your value is 15. H2 or R1, it doesn't matter for you. It might be different because when you make a dimension and you delete it, it will understand it as a new dimension, so it will make it H3 or H4. Let me show you how I made it. Let's delete this H2, delete it. Just a second, delete it. Perfect. Now, if I want to dimension this, it will say H3. It doesn't matter. It's the same thing. It's H3 and same thing. It doesn't matter. Okay, let's continue. Make a line that intersects with x-axis. Make sure PVC letters are visible. And select again, go down, make sure PVC letters are again visible. Click and finalize the boundary domain. We need to close the domain. Click here and click here. As you can see, it doesn't look horizontal, but I'm sure that ANSYS will understand and make this a horizontal line, as we can see. So everything is perfectly fine, vertical and horizontal lines. Now let's continue with geometry. Now I'm going to draw random two vertical lines, one of them positive, one of them minus y-axis, through y-axis. The distance between y-axis and the line that I have just created is, click dimensions, horizontal, click, click, and this dimension is 1 meters, chord length of airfoil or airfoil. Now click draw line, and let's make few more lines here so that we will capture the airfoil's velocity inlet way better, easier. Now what I want to do is give a dimension. This value I have taken from somewhere else, but it works. It almost works for every airfoil. Not everyone, supercriticals are kind of different, but you can try and find it. Now make sure this value is 0.08 meters. If these are millimeters for you, just multiply by 1000. That's all you need. That's all you need to do. And then we need to extend these lines to boundary domain, the upper side of the domain. Click modify, click extend, and click the upper side of your lines, not exactly top, but upper side, so that it will extend to the boundary domain, as we can see here. Now we need to create two more lines, that's all, and it will be finalized. The sketching will be finalized. Select the front of the airfoil, make sure P letter is visible, and select it. And make a horizontal line, it doesn't matter where you draw it. Let's do it like this. And click dimensions on the panel. Click, make sure you created dimension. H6, I'm going H6 on the details view on the bottom left. It is 6.67. I want to make this 7.5, which equates to my half circle radius. Perfect. Now final line that I need to draw. Click line, P, make sure P is selected again, and click to the very right of my domain. Make sure again P is visible, P letter. Okay, that's all for sketching. Now we are going to move on to modeling. In the modeling, we need to create a surface from our sketch. First we need to create lines from our sketch. We have drawn sketch, and make sure ANSYS understand them as and accepts them as lines. Let's click concepts, lines from sketches, drop down from here on our tree, click sketch 1, make sure everything is highlighted. Every line we have drawn should be highlighted, and click apply and hit generate button. Perfect. Everything is fine now. Now we need to again create concept, surfaces from edges, and we will select the outer boundary of our boundary domain. Make sure you selected all of the lines, even the tiniest details. Make sure you are holding Ctrl button on your keyboard so that you can select multiple lines. Yes, I think it's okay. Yeah, perfect. I click apply now. There will be 10 edges that you need to select and hit generate, of course. Okay, so ANSYS now understand this is a surface body. However, it accepts and acknowledges as solid body, and I need to convert this by selecting here surface, making this fluid, because our analysis is fluid. You can double click it, it will change, or you can just select from here or double click. It doesn't matter. Now let's move on. Let's move on to everything is fine. Okay, now we need to create boolean. Create boolean here. Add boolean from the create section. Make sure this is subtract, not unite. Target body is our fluid domain. Select randomly anywhere and click apply. Tool body is our airfoil. Roll down and make sure you are seeing airfoil perfectly. Click airfoil and select the second plane so that we can only select the airfoil, not the fluid body. Perfect. Hit apply. Then generate. So everything is fine now. Now final thing, we need to split the body by using the internal lines so that ANSYS understand where should we use better finer mesh and where should we didn't use, and also how to make it structured. You will see in the meshing part. Click tools, face split, select select the target face and hit apply, and then make sure the selection filter is edges. Select the inner lines that we have just created. There should be exactly 6 lines, as you can see here. And hit generate button. If everything is fine, Okay, let's continue. If everything is fine, you need to be able to see green check marks here. So there is no problem in our geometry. Final thing I want to do before going to the meshing part. These tiny lines creates a problem, the converging problem. So I will merge them. Click Tools on the ribbon and select Merge. Select these two lines. This is this tiny line, only the upper side, and hit Apply button on the Details view, bottom left, and hit Generate. And do it again for the bottom part of the domain. Tools, Merge, tuck, tuck, and hit Apply. And also Generate, of course. So I have finalized everything in our design modeler. I have drawn sketch. I have make my modeling. Now I can safely go to the meshing part. Everything looks fine. Now let's save it. Save our file by using Save Project. Click Desktop. And I will create a new folder here. You can previously have created, it doesn't matter. You can create it now also. Let's say like that, okay. And the name is same. And open this folder and save it. Wait a little bit so the software saves it. Perfect. Okay. You need to close the design modeler. Just a second. I cannot see it. Oh. Okay. Okay. And then we can move on to the meshing part. Just click Edit. Right click to mesh and select Edit from the dialog box. Meshing will take little time considering and comparing to the design parts, design modeler parts. You will see that in a minute. Give software some time to open it. It's not easy. Okay, I think everything is fine here now. Yes, okay, perfect. Now, first we need to indicate that we are going to try meshing the faces and the fluid boundary, fluid domain, sorry. So we need to suppress the line bodies. Click here, line body, and make sure this is suppressed body. Okay, the lines are suppressed, perfect. Now we need to insert some sizing to our airfoil and boundary domain so that we will capture the airfoil velocity contour and turbulence contours way better. Click mesh. Make sure your element size is 50 millimeters. This value is something that I have found by trials. And right click to mesh, insert sizing here. Perfect. Let's select the vertical lines of my boundary domain. I'm holding Control while selecting these lines, by the way. Do not forget that. Click Selection and hit Apply here. So these 6 edges should be selected when you done these steps. Now I will use the details view and change some of these. Type should be number of divisions. Make sure this is only 150. Capture curvature is no. I don't want to capture this on the little corners. Let's make the behavior soft for now, for this only, because I will add too many bias. I will explain what bias is later. Click bias type. Make sure the top one selected. And the bias factor will be 2000. If the bias factor, the lines are not getting smaller to the airfoil or to the airfoil domain, you need to reverse them. By using reverse bias, you need to reverse them. Hold Control and click these 5 lines. You might experience different case, but do the same thing. It should be looking like this, similar to this. lines should be smaller through the airfoils, or here, through the airfoil again. It's bigger when we go out, when we go to the far field of the airfoil. It's smaller when we go to the closer to the airfoil domain. Okay, everything is fine here. Now, insert sizing. I want to do face sizing here. Click the face, this and this. This is one of the most important points that we need to capture so that we can see the vortices or eddies in our contour. Click apply. Make sure your element size is, what was it? I think it was 15, I'm assuming. I don't remember what I have done, but I'm assuming it was 15. But let's make it smaller, let's make it 5. It will take time, but it doesn't matter. Capture curvature, again, no. The behavior, I want to make the behavior hard here, because I'm not trying to distort many geometry here. So I can make this hard, it doesn't matter. It's not a big problem, not a big deal. Now insert again, insert sizing. Click the horizontal. First you need to select edge selection filter from upper ribbon, from bottom ribbon here. Select edge. Click to the horizontal lines here. Apply. And select number of divisions. Make sure this value aligns with the previous value that we have just created for other lines. So it will be 150. However, I need to add this line also. Okay, now apply. Just a second. Cancel this. Oh, delete, delete. Insert sizing, same thing. Edge filter, okay. Horizontal, 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 and horizontal. I need to select these 4 lines and make sure this is number of divisions, 150. Capture curvature, no. Behavior, I want to make the behavior hard, and I want to add bias type, yes, the upper one here, upper one. Bias factor should be around 200, otherwise it might not converge or give good results, orthogonal quality results, etc. Now I need to reverse some of these bias, because it should be smaller through the airfoil and bigger through the far field from the airfoil. Click here, select this, this, this. No need to select this because it is smaller through the airfoil. Hit apply. Perfect. It's reversed. Now, finally, I need to add one more sizing here. I select these boundaries, these 4 boundaries, apply, number of divisions, and this value, after making capture curvature no, this value again should be 150 to align with the other horizontal line. And make sure your behavior is hard again. No need to add bias here. Insert sizing. We are going to do the final thing before we move on to the face mesh. Select this. Select this. To choose multiple lines, as I said before, you need to hold Control key. And select the front two divided, the splitted part of your airfoil. So 4 edges should be selected now. Hit apply. And this should be number of divisions. 100 divisions is more than enough for these parts. Capture curvature again no, and the behavior should be hard. I'm not distorting 2 different bodies. Like, what I mean that I'm not distorting vertical and horizontal in the same bias case. That's the reason I can choose hard. It's not that simple, but kinda like that. Now everything is fine. I will just insert face mesh here. I will select all of these faces, apply, and now I can perfectly generate my mesh. It will take some time. Let's wait. Perfect, everything is fine. This is a warning, no need to. Okay, we can visually look if our mesh is fine or not, and after that we will check from ANSYS if our mesh is fine or not. Just scroll down a bit and see your mesh is aligning perfectly with the airfoil, as you can see. And we have structured mesh. We don't need to use any inflation layers or sphere of influence, since this case is not too intricate or difficult. No need for that. Just make sure in the quality details of mesh, quality on the bottom left panel, make sure your mesh metric is orthogonal quality and the minimum value is above 0.1. That's enough for now. An average should be closer to the 1. The maximum value is 1. Okay, now we need to create name selections. I will click on the edge selection filter, select the outer boundary of my mesh, not the not the very right vertical line, because it will be pressure outline. Now I will click randomly anywhere, right click, create name selection, and this is going to be my velocity inlet. I'm going to type like this so that software understands and captures this as velocity inlet in the setup phase that we are going to move in few minutes. Again, we need to make 2 more name selections. Let's select our airfoil. Please capture all of the parts of your airfoil, highlight them, and also click randomly anywhere else and create name selection. This is airfoil. Perfect. Finally, we need to create pressure outlet. Select these 2 vertical lines on the very right of my domain and click randomly anywhere else, right click of course, create name selection, make sure this is pressure outlet. Okay, perfect. Hit OK now. Everything is fine, my meshes are perfect, my velocity, my name selections are perfectly fine. Here, I have defined them. Now I can move on to the setup. Let's save on the very top left corner of my meshing. I cannot show it because of Bandicam, I don't know why. And you can close the meshing after you click save. Okay, now we continue with setup. Before we move on, we need to update our mesh. Hit update. Wait a minute. Yeah, I can stop for now. Okay, everything looks fine. Everything is green checked. Now I can click setup and right click and edit. I want to upstream my mesh because I have updated, so click yes. We have made some changes in the mesh. The software says that. Make sure double precision is selected and make sure solver process is 4. You cannot select more because of your student version. If you have cracked version, you can select 6, 8, 12 or 16. Double precision to capture the vortices or the other things, contours better. Click start. Give some time for software to open Fluent now. Let me stop for a second recording. Okay, after you open setup, if everything fine, you will not get any warning or error. You might get information, I didn't, but you might. Just click OK or click X on the dialog box. Now we need to first select what type solver that we are going to use. Why it's not moving? Okay. We are going to conduct pressure based and steady, not unsteady like transient, because we just want to have a simple one airfoil analysis with few angle changes. I will explain all of them later. I will explain the insights of these things that we are doing in the software, aerodynamic insights, later on, don't worry. For click model on the very left setup, make sure everything is off and click viscose. Make sure SSDK omega selected. I will explain why we didn't select all of the other things. It's a long story. And then we move on to boundary conditions. Inlet, as you can see, software already understand it. This will be my velocity inlet. Even I wrote it wrong. It somewhat somehow understand it. Double click to velocity inlet. Make sure your specification method its components. Since we are going to change the angle later. Now we are not going to change, but let me explain it to you. Our x velocity will be, let's say, 45 meter per second. So it will give the air from only x-axis directly. It's not going to give from here or here or here, etc. It will give from exactly from x-axis to through my airfoil. Now y is 0, these are fine, apply. All the things should be detailed. Okay. No need to select these, just click reference values. Make sure you are computing from velocity inlet. Velocity should be 45 now. Everything is fine. You can leave them as it is. And click report definition. Right click, new, force report, drag and lift. Let's create lift for now. No need to do other one. Currently, click lift. Make the name, doesn't matter actually, CL, since we are going to get lift coefficient values. Click airfoil for a zone and make sure it's going to print the console so that we can see while software is calculating. Click OK. And finally, we need to, maybe you might need to change residuals. Click residuals. Make sure this is at least this value. For this case, steady and one airfoil, this is perfectly fine, but you might want to increase it a little. No need, but you can. This increase the accuracy, but in this case, no need for that. Click OK. Now we can move on to initialization stage. Make sure you are doing a hybrid initialization because we don't need to deal things by one. Software has a perfect way by doing hybrid. Click initialize, wait till it's done, and initialization is done. Now you can run calculation. Click run calculation on the left panel. For now, I want just to see a result, simple results, that if it's converging or diverging. 200 iterations and reporting interval is 20 is more than enough for my case. Okay. And hit calculate. It will take maybe 2 minutes, 3 minutes, that's all. I will see you later then. Okay, I want to show this. It's already, it doesn't matter, it's information. It's totally about named selection. If you do the named selection after you finalize your mesh and go to the setup, it will give this information. It's not important. Click OK. Okay, let's see our CL plot. It tried to converge in the first, let's say, 30, 34, yeah, 30, 34 iterations. And finally, it converged to this value, 0.42269 or something like that. It doesn't matter. It's too close to 42, 43. Let's see our contour. From results panel, you need to select graphics and double click the contours. I will select, I want to see turbulence now, and then we will see velocity later. I want to see the turbulence of my airfoil. Click airfoil. Also, actually, I want to see these as well, so that this might be a better visual for us. Yes, perfectly fine now. We can see the airfoil and the wake behind that. And then after I have visualized my turbulence contour, I want to see my velocity contour as well. Click velocity and save display here. Make sure these are selected. Perfect. This is my velocity contour. For 0 degrees of angle of attack, it's not going to create too much wake since my airfoil is not extremely cambered, or it's not angled. It's in 0 degrees. It's just creating a little wake behind that. And also, since this is a simple steady analysis, you will not be able to observe the wake behind the airfoil. We will continue with transient or unsteady analysis later on. And no need to do anything else from here. We can just maybe check if our CL value for NACA4412 and 0 degrees is correct or not. Let's open our validation. Okay, in the validation papers that someone on the YouTube I have found before collected, as we can see, for 0 degrees of angle of attack, coefficient of lift should be between 0.3 to 0.5, but closer to 0.5. So it should be around 0.4, 0.42, 44, etc. So even with steady and little number of iterations, we got the same CL value, as you can see here, 0.42 something, and it is for 0 degrees, go up, 0.40 to 40 something. It's not going to be exact, never, but it will be, the error will be less than 5%. If the error is less than 10%, it's perfect in your case when you do the analysis. Okay then, so we have validated that we found correct results. We will move on to more advanced things like changing this to the transient unsteady analysis. But before that, I want to explain shortly in the next lecture what is the logic behind that we are going to select steady, transient, density, or etc. I want to shortly mention that in the next lecture. Thank you for listening to me. Bye bye.